Okay, good evening, everyone. So today we are going to start the O-level ICT seminar, which is conducted by the Zonal Education Office, Gampa. So today is the first day. So first of all, I would like to thank Ms. Srimali, the Directress of ICT in Gampa Zonal Education Office, and ISA, Mr. Chanak and Mr. Jagat. Before we start, I will introduce myself. So I'm a teacher, ICT teacher. I was teaching at Takshila College at Gampaha. Now I'm teaching in Kandana Sebastian College. So in this seminar, we are going to, this will be continued for 10 days actually. So in this seminar, we are going to discuss most of the theory parts, plus model questions and past paper questions also. Especially model questions will be discussing at the end of this last few days. Before that, I am going to discuss some theory part, and we'll check what are the questions has come from those stuff from the past papers. I have extracted some questions, so we'll discuss them also. So now, if I tell about this seminar series, now there's another seminar is going parallelly to this one. That's a single medium one. I think most of the students are connected with this seminar is doing ICT in English medium. So this is English medium seminar because most of the seminars are in single medium. So I see those who are doing in ICT in English medium, they don't have much seminars in English medium. So in the exams even, English medium student have to write everything in English. But Sinhala medium student can write English and Sinhala both. But in English medium student, they have to write everything in English. So I think it's better to conduct this seminar in English medium. So you will be like learning everything in English. So it will be helpful you to write your exam, sit your exam properly, write your paper properly, right? So in the as a marking examiner, because I have experience like around 8 years of marking O-level and A-level also. So in marking, even now, if you take an English medium paper, you are not allowed to write anything in Sinhala. But single medium student can write Sinhala and English both, but English medium not allowed. So I think it's better to do in English, using the English medium only. So if you have any problem, just put a message to the YouTube chat, then I will check any problem. Even you can put a message there, right? Okay, we'll start. First day, I'm going to discuss number system part and logic gate part. So today we are going to discuss these two parts, especially this one. Most of the students are having problem with this stuff and the number system also. So first I will discuss about all the theory parts, all in the sense like most important theory parts. Then I will take some questions and see how they have come from these lessons, right? Okay, I will take the number system first. So when you take number system, you have binary number system, octal, decimal, and hexadecimal. Right? So these are the number system part that you have. So binary, when you take 0 and 1 is there. Now before that I will tell you, now first two lessons I have skip actually. I have skipped them because that's actually it's related to theory. So I'm not going to discuss them. You have to by heart some of them, and most of the theory parts are there, right? So I'm not going to touch them, right? So binary, you have 0 and 1, octal 0 to 7 numbers are there, decimal 0 to 9, hexadecimal 0 to 50. So in hexadecimal, you have 10, 11, 12, 13, and 14, and 15 will be represented with English capital letters. Right? So these are the letters you have to A, B, C, D like that. You have these letters to represent them. Now, when you take binary numbers, you can have values from 0 to 1. So if I write example 1010, so you can read it as 1010. But if I put the base value is 2 for this one. Octal, I will write 176. Octal, you have to put the base value 8. Here, decimal, you are not using, actually, you are not using base value there, but you can put 10. Hexadecimal, you take AB 9. So your base value is 60. So when you take this number system, you have numbers that is equal to base value. As example, binary number system, you have numbers 1 and 2, 0 and 1 only. That means 2 numbers. When you take octal number system, you have numbers from 0 to 7. That means altogether 8 numbers are there. Then decimal number 0 to 9, altogether 10 numbers are there. Hexadecimal 0 to 15, altogether 16. So base value is equal to a number of values inside that number system. Okay, then I will discuss now. I will go for the conversions. Before that, I will tell there's something called MSD, most significant digit and least significant digit. This is some students are confusing with this part. I'll take one example, 2560. Another one I'll take 02715. Another one I'm taking 62.1250. I put 0 here. Another one take 0.01230. Right? Now, if I ask you to find out the MSD means most significant digit. The rule is you have to take non-zero first rank. Non-zero first rank. So MSD is, here MSD is 2. Here MSD is again 2 other than the 0. Here MSD is 6. Here MSD is you are taking non-zero first rank, that is 1. Okay? So LSD means last value for the whole number. That means you can take, now this is 2560. You can take 0 as the LSD, doesn't matter. Now suppose you don't have 0, the value will be 256. If you put a 0, 2560. That means 0 has a value there, right? So you have to take LSD as 0. Here LSD as 5. But when you take the fraction part, you have to take non-zero last term. That is the rule, non-zero last term. So here it should be 5 here. This should be 3. So these things, some students are making mistake. If you want, you can take it down quickly. Okay. So same way you have something called MSB and LSB. I will teach that part also. MSB, most significant bit, least significant bit. Now this is related to binary values. So if I take the binary value something like this, same way, rules are same. So MSB first non-zero value. LSB, if it is a whole number, you can take 0. If it is a fraction, you have to take non-zero last value. Non-zero last value. You won't take it down also. This is for binary. Most significant bit, least significant bit. Okay. So then we'll go to a conversion part. I think conversion part is easy for you all, right? So conversion part, when you take decimal number, you can convert to binary, octal, hexadecimal. So what you have to do, if you want to now, I will take 25 as number decimal now. If you want to convert it to binary, you have to divide by 2. So I will do that here. 1, 2, remaining is 1, 6, 0, 3, 0, 1, 1. So from bottom to right, you can write the answer 1, 0, 0, sorry. 1, 1, 0, 0, 1. And you have to put 2 as the base value. If I take, we'll take 25, same thing. 25 octal, you have to divide by 8. So how many 8s are there? 3. Remaining is 1. So your answer will be 31 in octal. I'll take the same thing. 20, I will make it 26, then you can understand it better. 26. You are dividing by 16. You are dividing by 16. So 16 is there, remaining is 10. But when you are writing the answer 1A, your answer is 1A for the hexadecimal value, 1A, right? So if you want, you can take it down. I think these things you have, you are okay with these things. So whatever the decimal number, if you want to convert it to binary, you have to divide by 2. If you want to convert it to octal, you have to divide by 8. That means base value. If you want to convert it to hexadecimal, you have to divide by 16. Right? Okay. Then I will go to the other way around. I am going quickly for the theory part. Other way around, it means what? If you get a binary, how to convert it to decimal? If you get an octal, how to convert it to decimal? If you get a hexadecimal, how to convert it to decimal? So I'll take binary 1, 1, 0, 1. So you have to put the values 2 to the power. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 3 is 4. Sorry, 2 to the power 2 is 4. 2 to the power 3 is 8. Right? Now here, if you have 0, you are not going to add that relevant value. Otherwise, you are going to add. So here you have to write 1, 4, 8. So altogether, you have 13 as the answer. 13 as the answer. Octal, I will take octal value 2, 4. Here, 8 to the power 0 is 1. So whatever the value, power 0 is 1. Remember that. 8 to the power 1 is 8. So here, 1 into 4 plus 8 into 2. That means 16 plus 4, your answer will be 20. Then hexadecimal, I'll take A, 3. So 16 to the power 0 is 1. 16 to the power 1 is 16. So if you have 16 to the power 2 is 250, like that you have to go. Now here, 1 into 3. Now here I didn't put any zeros. If you put a 0, you are not going to take that value. Remember that, right? 1 into 3 plus 16 into m is what? 10. So 160 plus 3, you get 163. That is in decimal, right? So if you want, you can take it down quickly. Okay, then you have something called, now you know how to convert decimal to binary, octal and hexadecimal, and vice versa. That means hexadecimal, octal and binary, you know how to convert it to decimal. Now I will tell you, if you get a binary value, how to convert it to octal, how to convert it to hexadecimal. So if you get a binary value, I will write something like this. You have to separate each 3 digit. Digit 3 වෙන් කරන්න ඕනේ. එහෙනම් මම මෙන්න මෙතනින් වෙන් කරගන්නවා. Right? Then I will put the values like earlier. 2 to the power 0, that is 1, 2, 4. Again, 1, 2, 4. Like that. If you have 2 values even, doesn't matter. 1, 2, like that you have to put. Now here the same way what we have done for the finding decimal. Here you don't have any values for zeros. So here you get 1. Here you get 1 and here 4. So 51. So you have to write the answer by concatenating. That means 5 and 1, 51 as the answer in octal. Hexadecimal, same way. You are going to separate each 4 digit. Each 4 digit. So again, you put the value 1, 2, 4, and 8. Again, 1, 2, 4, 8. Here you get 8 and 2, 10. Here you get 8 and 4, 12. But in hexadecimal, when you are writing the answer, 10 you can represent with A, 12 you can represent with C. So A, C in 16. But so very easy. When you are separating, remember, you have to start from right-hand side. Huh? You have to start from right-hand side. Otherwise, you'll be getting a different answers. You won't take it down. Okay. Then other way around. That means if you get octal and hexadecimal, how you are going to convert it to binary? how you are going to convert it to binary from the Excel. So octal, I will take 7, 2. Octal. So each value you have to represent with 3 binary digits. I will write something like this. 1, 2, 4. So if you want to make 2 value, 2 karanona, you have to put 1 here and zeros. These are zeros. So I will write 0, 1, 0. It's easy, I think, right? Okay, then 7, how to convert it to binary? You can divide by 2 and get the value like earlier, doesn't matter. I'm telling that shortcut here. So 7, you have to take 4, 2 and 1. When you add them together, you get 7. So you can write very easily 72 in octal. You can convert it to binary like this way. I'll take hexadecimal one. C9. So when you take hexadecimal, you have to represent each digit with 4 binary digits. So you have values 1, 2, 4, 8. We can put like this. 9, you can make it 8 and 1. Others you make it 0. So I'm writing here 1, 0, 0, 1. Right? C is 12. 12, how to create? 8 and 4, that is 12. Other things 0. So 1, 1, 0, 0. Easily you can find out the answer. Right? If you want, take it down quickly. Okay. Then we'll see. Now we know how to convert when you get a binary to octal and hexadecimal. Then other way around. When you get an octal, how to convert it to binary, and when you get a hexadecimal, how to convert it to binary. Then you are getting something like this. Octal to hexadecimal and hexadecimal to octal. Right? Now we'll take one value, we'll take 75 in octal. First, you have to convert it to binary. Now you know how to convert it to binary. Each digit you have to keep it 3 binary digits. So 7, I can write 1, 1, 1, 5, 1, 0, 1. I'm writing quickly. Now you know how to do that. Now that value, how to convert it to hexadecimal, you have to separate each 4 digit and put the values power of 2 to the power 0, 1, 1, 2, 4, 8. Here 1 and 2. So here you get 3. Here you get 30. So your final answer you can write 3. 30 means D. When you get an octal, I have converted to hexadecimal. The other way around. I'll take 2B in hexadecimal. Again, you have to convert it to binary, but you have to keep each digit with 4 binary digits. 2, I can write 0, 0, 1, 0. B, that is 11, 1, 0, 1, 1. Then separate each 3 digits from right hand side. Remember that. So again, you put the value 1, 2, 4. Again, 1, 2, 4. Again, 1, 2. So here 0, no need to put that 0 even. 5, 3. So your answer will be 53 in octal. Right? So I'm going a bit fast because now you have done this stuff. So I am trying to brush in up your knowledge, right? So this is 75. That is octal, hexadecimal, again hexadecimal to octal. Right? Now you have done this stuff, so you can quickly grab this stuff. I believe like. Okay, then we'll see. Now those are the things that you will be getting. Other than that, you have something called coding systems. BCD you have, ASCII, EBCDIC, and Unicode. So here the number of bits you are going to use. BCD you are going to take 4. That means you can represent 2 to the power 4 equal 16 characters. ASCII you have 7 bit, 2 to the power 7, 128 characters you can represent. EBCDIC you have 8 bits, 2 to the power 8, 256 characters you can represent. Unicode you have 16 bit, 2 to the power 16, 65,536 characters you can represent. Nowadays we are using Unicode. Because of that, we can represent most of the languages like Sinhala, Tamil, whatever the language we can represent. We can type them in the computer because of the Unicode, right? So here you are getting question from this table. Definitely you will be getting a small question like how many bits are there, how many characters you can represent, like that. So other than that, you will be getting some questions from BCD. You'll be getting. That means if you want to now from BCD 0 to 0, 1, 2, 3 like that, you have values from up to 9. Each value you will be represented with 4 binary digits. So you know how to convert it to binary now, like that, right? So if you get a value, decimal value 57, and asking to make it BCD, you have to represent each value with 4 binary digits. Now here even you get zeros in front, you have to put them. Don't miss them. But when you are converting, you can miss them. But here BCD, you cannot miss them. So 5, I can write 0, 1, 0, 1. 1, 0, 1 is the binary value for the 5, but I am using 0 because make it to 4 binary digits. 7, 0, 1, 1, 1. So this is my answer. So if I put another BCD value and asking you to convert it to decimal, so separate each 4 digits. Here you get 1, 2, 4, 8. Here you get 1, 2, 2. So this is the answer. So remember, BCD has values from 0 to 9. If I write a BCD value, this is from why? Here you get 12. 12 is there for the BCD? No. So exam find out the incorrect BCD value. Binary, sorry, BCD, for the BCD you have values from 0 to 9. Remember that. Then other way around. Okay, if you want, take it down quickly. Okay, then we'll see in ASCII even you are getting questions. ASCII, how you are getting questions? ASCII has a linear way of like representing data. That means there are no need to by heart the table, which is in your unit 3. At the end of the unit, you have a table. Table එකක් තියෙනවා ඒක by heart කරන්න ඕනේ නැහැ. දැන් අපිට දෙන question එක. අපිට කියනවා මෙහෙම 65 is A. Find out the ASCII value for C. Now අපි දන්නවා 66 is B, 67 is C. So 67 you divide by 2 and get the binary value. And that is the binary value you are getting for the ASCII. But remember, you have to keep it with 7 bits. You have the 7 bit for the ASCII values, right? Now, I think that's all for the number systems. I went quickly. Then we'll go to the logic gate part. When you take the logic gate, there is a unit 4. So logic gate we are using to, now in the computer, you know that values, computer can understand only ones and zeros. So inside the computer, it is changing. Ones become 0, zeros become 1, like that it is changing. So you have separate logic gates to do that, right? Separate logic gates to do that. Now, when you take logic gate, you have, if you have, this is called input, this is output. All the time you have only one output is there. You can have inputs, several inputs you can have. 2 inputs, 3 inputs, 1 input, right? So how many patterns you are going to now? You can have either 0, 1, 4, any from these inputs, you can have only ones and zeros. You can't have any other values. So if you have 1 input, you can have 2 patterns to the power 1. If you have 2 input, to the power 2, 4 patterns. If you have 3 input, to the power 3, 8 patterns. If you have 4 input, 16 now. For the A level, you will be getting 16 questions even. But I believe for the O level, you're getting up to 3 inputs, 8 patterns, right? So we'll see these patterns and the logic gates. You have to memorize this. Make a memorize karagatta logic gate karaganna hambennema naha. AND gate is there. Symbol is like this. I will take input as AB 0 0 0 1 1 0 1 1. This is called truth table. This is the gate. You are writing AND gate A dot B. If you see the dot, that means it's an AND gate. Without dot even you can write an AND gate. Even you don't have a dot, that is also AND gate, right? So AND gate, your truth table is 0 0 0 0 0. Your output will be 1 when you both inputs are 1, right? If I write O gate like this, you take AB as input. You can write A plus B. If you get 0 0 as input, your output will be 0. Otherwise, all are ones. Then other way around. NAND gate. NAND means other side of AND. Now, if you can remember AND, other side of AND, A dot B dash, you can write 1 1 1 C. Other way of AND. Other way around. 0 0 1 for the AND, 1 1 0 for the NAND. I think it's easy for to remember. NOR gate. Other way around of OR gate. That means here you get 0 1 1 1. Here you are writing 1 0 0. So other than that, you have a NOT gate like this. If you input A, you get A dash. So you have 1 input. So 2 values, 0 become 1, 1 becomes. So without having these things, without remembering these things, you will never able to complete your logic gate question. You have to memorize. You have to remember. I think it's easy. දෙකයි හරියට මතක තියාගන්න ඕනේ. අනිත් දෙක නිකම්ම මතක තියාගන්න පුළුවන් other side. And not gate dash. Right? I think this is in your textbook also tables. So no need to write it again and again, but you have to memorize. Then you will be getting 3 different types of question from this part. So I will tell them. First part is you are given a circuit. And asking for the output. This is the one way of getting question. Now, when you get something like this, don't try to write the final expression at once, right? Can try, but it will mislead sometimes. So you better find out output for each gate. Then it is easy for you to find out the final outcome. So here this is first you have to identify the gate. So here it is an AND gate. So if you input AB, your output will be A dot B. Here A going through a NOT gate, so A dash, and B is coming to the NAND gate. So your answer will be A dash dot B, again whole thing dash. Now don't go to simplify. Simplification is there for the A level, but in your syllabus, earlier it was there, before 2016, but you don't have them at the moment. So don't worry about simplification. You write like this, A dash and B connecting with the NAND gate. So because of the NAND gate, dot and dash is come. Now finally, these two are connecting with the OR gate. These two are connecting with the OR gate. So you can write A dot B here from this side. From this side, A dash dot B dash connecting with the OR gate. OR gate means you can put a plus mark. If you want, you can make it a bracket T. Right? You want, take it down quickly. How to find out the expression for the given logic circuit. Okay, next way of getting questions. You are getting the expression and asking you to draw the circuit. Draw the circuit. Now here you have A dash. So how to draw A dash? You have to use a NOT gate. B dash. You have to put a NOT gate and connecting with A dash and B dash connecting with dot. Dot means AND gate. Right? Now here AB there's a dash, but it is for the whole thing. That means it is not a NOT gate. Remember, right? It's not a NOT gate. It is a NAND gate. Right? So NAND gate, if you want, you can make it to AND gate and put a NOT gate. That is also possible. But I'm not going to draw like that. I am using single gate, NAND gate. And connecting with what? Plus. Plus means what? OR gate. This is how you have to find out draw the circuit for the relevant circuit expression given with. Okay, take it down if you want. Okay, then other way around is you are getting this kind of expression and you have to draw the truth table. You have to draw the truth table. Now here two inputs now. I will take the same example. 0, 0, 0, 1, 1, 0, 1, 1. These are the patterns you can write. Right? Then A dash. I will write separately. A dash means other side of A. 0 become 1. 0 become 1. Then B dash, other side of B. 1, 0, 1. So A dash dot B dash. Now you have to remember the truth table. And gate, you are connecting with A dash and B dash. So 1, 1 become 1. 1, 0, 0, 0, 0, 0. Right? That is AND gate truth table I have to remember. Then I will write A dot B dash together. That means again A and B, these two now, not these two. These two connecting with NAND gate. Here you get 0, 0. Sorry. Here you get NAND gate 0, 0 become 1, 0, 1 become 1, 1, 0 become 1, 1, 1 become 0. NAND gate. So you have to remember. Now these two are connecting with OR gate. These two connecting with OR gate. 1, 1 become 1, 1, 1. Here you get 0. So your answer will be like this. If you want, take it down quickly. Okay, then these are the basic things that you will be getting questions. So other than that, you will be getting some kind of a scenario. Given scenario, like there are three sensors, these sensors working together, something like that. When you get something like that, you have to find out the logic gates related to that one, and especially sensors and all that. Right now, as example, if I tell something like this, there are three sensors. If two sensors are working together, your alarm will be working, something like this, right? Now, if I put the values for the sensors, because of the three inputs, you have 8 patterns. These are the patterns. If I tell alarm, how the alarm is working, if two sensors are working, your alarm will be working. So here it is not working. Here even, here. But here two sensors are one. So your output will be one. Here you don't have. Here it is working. Here it is working. Here it is working. Right? So something like this. It depends on the question. So we'll go through the past few question and we'll see whether you have getting any type of question like this. But these kind of questions are coming for the actually for the A levels. Students, you are getting a bit difficult question, but for the O level, you don't get this much of big questions, right? So we'll go through some question. I have extracted some question from the past papers. I will share that, and we'll try to find out the answers for them. Okay, I think you can see them. Some of them from 2019 question paper. Okay, try to find out some answers now. I think you are okay with this stuff. I believe you can answer without any problem. Now, these are from 2019. There are 3 MCQ from the number system and the logic gates and some other structure type questions are there. Okay, I will give small time to try to find out the answers. Okay. We'll go through the first question. 2019, which of the following statement are true? Binary form is used to store data and instruction in computer. That is correct. I told you that binary value, that is 1 and 0, are using to communicate with compute. 945 is a valid number both in octal. Is it octal? No, because of the 9. You know that in octal you have numbers from 0 to 7. So it is wrong. Then 412 in octal is equivalent to given binary. So you have to convert it to binary. You have to separate each 3 digit. Here also same. So here you get 2 and 0. Again 2. Sorry. I think separating 3 digit, I have made a mistake. Here you have to separate. Here you have to separate. Yeah. So here you get 4, 1, and 2. Yes. That is correct. So C also correct. A and C. Third answer. Third answer. Then we'll go to next one. E is represented with 69. So they are giving E equal 69. What is the binary representative of G? So you know that it has a linear method of representing the value. So A, B, C, D, E, F, and G. So F is 70, G is 71, right? So now you find out how to convert it to binary. 71, you have to convert it to binary. So it is actually 64 plus 7, you get 71. So 64. 1, 2, 4, 8, 16, 32, 64. Like that, you can find out the convert into a decimal. You know how to do that. So your answer will be second answer. Second answer. 64 plus 7, you get answer. Then 40th question. I will use the board for that one because I can remember most of the students had made a mistake in paper marking. If 0 and 1 respectively are given as input for X. So X, you are giving 0 and 1 respectively. That means first you are giving 0, next you are giving 1. What would be the 2 respective output at A? Sorry, Y. So I have taken it to the board. Now X, if I put X as 0 at the beginning, so what will happen? This will be 0. That means with the AND gate, whatever it is for the B, your output will be 0 here. Can't tell, right? Because one input is 0, definitely the other one is 1 even, your output will be 0. If it is 0, this will be 1, right? This will be 1. If it is 1, if A equals 0, your output will be 0. If A equals 1, your output will be 1. So it depends on 1. So in the no, it is this finally you have a OR gate. Here you are getting 0. If you get 0 from here, your output will be 0. If you get 1 from here, your output will be 1 here because of the OR gate. So it depends on the value of A. If A equals 0, your output will be 0 here. Then final output will be 0. If A equals 1, your output will be 1. Your final output will be also. That means whatever the value you are giving it to the A will be the output. So if you input 0, your input depends on A. Whatever you are giving for the A will be the output, right? Then we'll see if you give 1 for the X, what will be the output? If you give 1, so definitely this is not going through a NOT gate, no? So it becomes 0. 0 means whatever the value doesn't matter, your output will be 0. So if B is 0, your output will be 0, your final output will be also 0. If it is 1, because of this one, your output will be 1, final output will be 1. So that means if you give 1, it depends on the value of B. So you have to write that way and find out the answer. So we'll go through the question. Now you have seen, if you input 0, your output will be A. If you put 1, your output will be B. So your answer is second answer. Okay. Then we'll try to do now you can see there are 3 questions, that means 3 marks. Then you have another 2 questions from the structure. That means each question you get 2 marks. That means 4 plus 3. You get 7 marks. You got 7 marks for 2019 question paper. So it's a big value. Big value. If you are trying to go for A, definitely you have to do this stuff without making any mistake. Okay, we'll go to third one. Convert 1260 to octal. You have to divide by 8. Divide by 8. So here 1, 46, 5, 60, 7. 4 remaining. Again, you have to divide by 8. 1. Then you get 70. 7, 77. 9. 72, 5. Then again divide by 8. 2, 3 remain. So 2354 in octal. Right? Convert A1 to its binary equivalent. A1. Keep each value with 4 binary digits. 1 you can represent 0, 0, 0, 1. A is 10, 1, 0, 1, 0. So your answer will be 1, 0, 1, 0, 0, 0, 0, 1 in binary 2. Right? Then next one. Okay, try it out. A and B. This is related to logic gate. Try it out. Now for the next one, you have 2 columns. A is the one input, because same input is going to divided into 2. P is your output. So A is one input. You have only one input. So that is separated into 2, doesn't matter, but only one input is there. So it becomes 0 or 1. So when it goes from 0, 0 for the NOR gate, what will be the output? 1. If you give 1, 1 for the input, it is an OR gate, you get 0. So this is your answer. Because I can remember some student have put 0, 0, 0, 1, 1, 0, 1, 1. That's wrong because you don't have two inputs. Only one input is there. Okay, next one. Consider the following logic circuit. Write down the relevant Boolean expression. I think you can remember we have discussed something like that. So here you have a NOT gate. So it is Y dash is coming from here. So your final output, you are getting X dot Y dash. From here you get X dash dot Y. Your final output you can write X dot Y dash plus X dash dot Y. This is the final output. So very easily you can find out the answer. Okay. Then we'll go to the 2000, we'll see. Yeah, 2020 questions. Okay, try to find out. There are 3 MCQs and 2 structure. There is 7 questions came from the 2020 paper also. Okay, I'll give small time to try them. Now in the first question, which of the following represent the given 4 numbers in ascent? Ascending means small value to the big value you have to go. Now what you have to do is you have to definitely convert them to the one type of number system. I think it's better to convert it to decimal and find out what are the values. Then you can easily find it out. Now if you take 64 in hexadecimal, your decimal value is 6 to the power 0 and 6 to the power 1. Here you get 100 in decimal. Then you have there's an octal value 226. If you convert it to now you know how to convert it. to the decimal, 8 to the power 0, 8 to the power 1, 8 to the power 2. So you get 150. So 200 is given in hexadecimal. No need to convert. Binary, if you convert 101011, your decimal value is 43. So now you can understand what is the smallest value is 43. That's a binary value. Largest value is 200 in decimal. So your answer will be second answer. Second answer. There you have to convert them quickly. Otherwise, it's difficult. By looking at, even you can manage to convert, but it is difficult for everyone. So everyone can do conversion. Okay, we'll see next one. Which of the following expression is equivalent to the output of the... So here you get x dot y. X dot y. Here you get y dash plus x. Now I told you to find out the answer separate, then it will be easy. Then final answer all together, connecting with O gate. So x dot y plus y dash plus x. First answer will be okay. Next one, try it out. Here your output will be a dash dot b. Then asking which of the following logic circuit has a truth table equivalent to the above logic circuit. So you better to draw the truth table for each one. So AB is the input. So I'll put 0, 0, 0, 1, 1, 0, 1, 1. So A dash means A dash. I will put dash like this way because when I'm typing, A dash means 1, other side of A, 0, 0. Then your final output, A dash dot B. Here you get 0. Here you get 1. Again 0. Again 0. So this is equivalent to what? Here you have A plus B dash, again whole thing dash. So if I find the truth table this way, AB, B dash I will write first, other side of B. Now I'm going to write the full answer, A plus B dash, then whole thing again, dash, because of the NOR gate, because of the NOR gate. So A plus B dash dash. Now I have the B dash, I have the A, So 0 plus 1 with the NOR gate, you get 0. Then 0, 0, you get 1. Again, 1, 1, you get with the NOR gate 0. I told you 1, 0, 0 because I told you to remember the truth table. Otherwise, you can't manage this. Otherwise, you can't manage. So I think from the first answer, you will be getting the answer. Ne? First equal. So this is the answer. Okay. I think you are clear with them all. We'll go to third part, convert the octal. Convert the octal number 867 to its binary equivalent. Show the major steps to your calculation. Here you got free marks. Why is that? Because can you have an octal value with 8? No, it's a mistake. So in the paper, there was a mistake. So you got 1 mark free. So what you have to do is, you have to separate each digit and represent with 4 binary digits. But you can't have 8 there. So you got free marks now. But you know how to do that by converting them to, by representing them, each number with the 3 binary digits. You can do that. But here you can't do because of the 8. So you got free marks there. Then next one, is said, ASCII code is given. What is the ASCII code for Y? Now, what you have to do, you have to find out the answer for this one. Now, you know how to calculate. If you have a binary value, how you are going to convert it to decimal. First, you have to convert it to decimal. Now, you know 10, 11, 0, 10 is there. So, you know 1, 2, 4, 8, 16, 32, 64, like that you have to put there. Then find the answer, you'll be getting decimal value 90. When I convert it, I got 90 there. So 90 is what is it? Capital is it. So X is where? XY is it. I will write the sequence because I told you this is a sequence. Linear model is there for the ASCII. So 90 is Z. Y is 89. X is 88. Now what you have to do, you have to find out binary value for the 88. Your answer will be 1011000. You can deduct 2 actually. So you have to represent with 7 bits. If you put 8 bits, that's wrong. Huh? ASCII code, you have to have only 7 bits. Okay, next one, draw the truth table for the logic circuit given below. Now we have done that kind of questions. Draw the truth table. You have only 2 inputs, A, B only. 0, 0, 0, 1, 1, 0, 1, 1. So first thing is AND gate, A dot B. I'll write here. A dot B, 0, 0, 0, 1. Next one, B plus A. B plus A. Okay. 0, 1, 1, 1. Finally, you have A dot B plus B plus A dash. That means with, sorry, A dot B dot B plus A, then whole thing you have to put here dash because of the NAND gate. Because of the NAND gate. So NAND gate, if you input 0, 0, your output will be 1. 0, 1, 1. 0, 1, 1. 1, 1, C. So that is the output for the NAND gate. That's why I told you to memorize those logic gate symbols and the root rate. You will never able to do these questions if you don't know, if you can't remember. Okay, we'll go to 2021, last year paper. Okay. There even you get 1, 2, and other 6 marks are there. Okay, try it out. Okay, 2021 also, if the character A is represent given a value, in ASCII coding scheme, what character will be and given the some value. So here you have to convert them to decimal and find out. Now first value is 1 0 0 0 0 0 1 is 1 0 0 0 0 0 1 is 65. So 65 is A. Here value will be 1 0 0 0 1 0 0. That is 68. 68. So we'll go through like this way. A, B, C, D, E like this, right? So here A is given as 65. They have given. Don't worry, no need to memorize. Then B is 66. C is 67. D is 68. Answer will be third one. Then again, which of the following represented given the 4 numbers in descending order? The same way you have to convert them to either decimal. It's better to convert them to decimal. Now, if I take the First binary value, if I convert it to decimal, now you know how to convert it. So I'm not going to teach that part again. 158. This you get 158. Then 157 is there in the decimal. No need to convert it again. And you have a hexadecimal value 9C. 9C is equal to 156. Now you know how to convert it. 156. Then another value is there in octal. 233. When you convert it to decimal, you get 155. 155. That means now you are asked to find out the descending order. Descending means the largest one comes first. So 158 is coming first, 157 next, 156, 155 last. So first answer, what I have found is correct. Okay. We'll go to the last part. Convert 47 into binary. Very easy. What you have to do? You have to divide by 2. 47. Your answer will be 101111. 32 plus 15, you get 47. Following as an extract from the ASCII table, write down the correct octal value represent for the question symbol. A, simple A, 97. Hexadecimal is 61. Binary is given. Very easily you can have the binary. If you have the binary, you know how to convert it to octal. Separate each 3 digit. Then your answer will be 1 and 4, 1. Draw the logic gate circuit for the following Boolean expression. I will draw it here. C dash plus AB dash. So C, I'll take a NOT gate. AB dash, again, NOT gate. AND gate, and connecting with OR gate. C dash plus A B dash. Write down the value of F when A equals 0, B equal 1, and C equal 1. Right? Now I will tell you that one. A is 0, B equal 1, C equal 1. Okay, I will stop sharing the paper. I think that is the last question, right? Now, this kind of question I can remember came for the Western Province paper, even this term test, right? Most of the students were trying to find out the truth table. They have written the truth table and find the answer A, B, C, everything. No need to do like that. Why? Now the expression is given here, right? Here A is 0. I am assigning it. A, I am assigning 0 for that. Dot, here dot. B is 1, here B is 1. So B dash means 0. Plus C is 1. Then C dash means 0. 0 plus 0, 0. What is the answer? 0, 0. 0 dot 0 means 0. Again 0 plus 0. That means OR gate, 0 and 0. Your output will be 0. No need to draw it. Draw the truth table. right? Very easy, you can do that, right? So one student is asking what's the difference. A dash and B dash is how to draw? Two NOT gate with an AND gate, right? If you take A dot B whole thing dash bar, you have to draw the NAND gate. That's the difference. So it is totally different. It's totally different. This is something else. This is something else. Right? Two different. Now here, this kind of question, you don't want to draw the truth table. If you draw the truth table, you'll be getting all zeros as output. Doesn't matter, but it takes long time. Don't do something like that, right? So you can assign the values. If A equals 0, you put 0 there. B equal 1, so you have B dash. So you have to put 0 there because B is 1, B dash means 0. Other side, C is 1, C dash means 0. Right? So easily you can find out the answer C. Right? Okay. I think that's all for the day. I have planned to discuss actual number system and logic gate today. So I think I did it successfully. Right? I hope I have done it successfully. So in next day, we'll be discussing another kind of taking another unit and we'll discuss them. And I thought of discussing the programming part by taking at least 2 days because Pascal know that all that because most of the students told me that it is a bit difficult for them. And definitely we'll be getting around 3-4 MCQs and essay type question and sometimes structure from the Pascal and all that. So we can't just neglect that part and go for the exam. Then you will be not able to go for a pass, right? So we'll take like 2 days and try to find out the I thought of like doing from the beginning flowchart, pseudocode, and Pascal together, right? So okay. So thank you very much. I think again we are meeting on 11th. I will put it to the group, right? Link and all that. So go through these things and try to find out other question that is related to from 2007. Even you are getting question from these 2 units. So try to find out the questions and try to do them because you will be having the exam on 15th. So you don't have much time. So try to work hard in this time. Definitely you can go for A pass. And if you have any problem, you just put me a WhatsApp message, then I can reply without problem, right? Okay, thank you very much. Good night and have a nice day, everyone.